name is Matthew Rogie. I am a forestry technician at Frost Campus or Sanford Fleming College. This is my partner here.
I'm Gareth Cockle, and I'm also a student in the forestry program. Today we're going to talk to you about scaling and determining the volume of wood in a log, both in a log and in lumber form. So today we're going to review both metric and imperial, using a scaling stick, some simple props, and just a bit of mathematics. In metric, we're going to quickly discuss cube grade, and standing tree.
And in imperial, we're going to discuss the Doyle rule, the Ontario log rule, as well as lumber scale.
So just to review some of the basic theory behind finding the volume of the log. Typically what happens is we have two faces of the log, one which will be larger than the other according to taper. So the bottom end or the butt end will usually be the thicker end, and the top end will be thinner. Now what we do so that we can measure many, many logs in a skidway is we assume that we'll have an even distribution of tops and bottoms. Doing that, what we've essentially done is we've averaged the size of each face so that we can have an even taper. So instead of being 22 centimeters at one end and 20 centimeters at the other, we assume that it becomes 20. We also then have a length. The length in this case we're going to call 5.1 because this is one of the most common. We measure it in meters in cube grade and we measure it in feet in imperial. In this case, all we have to do is we have to take the average diameter, we square it, we multiply it by these magic numbers which are manipulation of pi and are 0.7854. Then we multiply it by the length in meters, which in this case is 5.1. Then we divide everything by 10,000, and we are given a volume in meters cubed. What a scaler in Ontario has is two very handy tools. He has a scaling stick, which he can use to measure the diameter of a log, and he has tables, which are found on the actual stick. In addition to these, we have the scaling manual, which is by no means a guide, but is in actual fact a manual, and you have to adhere to it. Within this, we have tables for calculating volumes. And so I know that automatically, if this log is 5.1 meters in length and is 20 centimeters in diameter, I can go into my manual and find here that it is 0.16 meters cubed. At the end of the day, all you do is you break down all of your diameters and you take into account your defects. And then when you're in the pickup at the end of the day, you just go through your tables, you find your appropriate length, and you write down the right number. When you've done that, you tally everything, and that's your total. Then you apply your stumpage charge.
Theoretical situation, we have a truck hauling 20 meters cubed of timber out of the forest. This is to give you an idea of stumpage costs. We have 5 meters cubed of white pine, 7 of red pine, and 8 of black spruce. Basically, stumpage is charged by meter cubed. We have a charge of $5 for white pine, $3.50 for red pine, and $3 for black spruce, resulting in a cost of $25 for the white pine stumpage charge, $24.50 for the red pine, and $24 for the black spruce.
Now the reason stumpage is so important in Ontario is because stumpage goes to the Forest Futures Fund, which ends up paying for the roads and subsidizing the forestry industry. Without this, Ontario wouldn't be able to compete with international markets, and especially exporting to the United States of America. Now I'm going to talk about finding the volume of a defect in a log so that people pulling wood out of the bush with a sustainable forestry license aren't paying too much stumpage for their wood. Now finding the volume of a defect in a log is pretty much like finding the volume of the actual log itself. You'll take a defect volume and you'll take a gross volume and you'll subtract the defect volume from the gross volume. Fortunately, what we have to do in the field as a scaler is you simply use your tables. So first we're going to find the diameter of the actual log. And here it's 36 by 38. Now if we use the rounding rule of 4, we'll average that out to 36. Then we're going to pretend that the heart of this yellow birch is the defect. And we'll measure it as 22 by 22. Then when you're in the yard, all you have to do is look to 36, look under your table, and you'll find that a defect of 22 removes 8 centimeters off of the 36 diameter class, which will bring it down to a 28. From 28, we write that down on our sheet. We can go back to our table once we're at the end of the day and sitting in the truck. And a 28 centimeter log at 5.4 will be equal to 0.314 meters cubed. It's that easy.
All right, I'm going to be talking about an imperial method, which is the Ontario log rule. Using my official Ontario scaling stick, I'm going to measure the diameter inside bark of this log real quick. So I have 15.5 and 16 inches, so I'm going to go ahead and round up to 16. Hypothetical situation, assuming this log length would be 10 feet long. I can pull out my handy dandy chart, select my diameter of 16 inches and my length of 10, and I know there is 101 board feet in a log that size. So using the same log as a reference, we're going to now talk about the Doyle log rule. This rule was put into place in order to maximize production at sawmills. This is by rewarding larger sized logs brought into the sawmills and penalizing smaller logs. So to show an example, as we talked about in this log earlier, we were rewarded with 101 FBM for the Ontario rule. This same log under the Doyle rule only yields us 90 FBM.
Now the reason for penalizing small saw logs and rewarding large saw logs is simply because they both require the same amount of handling time. But in a small log, you'll find significantly less mercantile volume than you would in a large saw log. Now I'm quickly going to take you through lumber scale. Now lumber scale essentially takes a pile of lumber, and we can find out how many board feet are in it, even if the boards aren't cut into 1 inch by 12 inch boards. Now it's very simple. All we do is we find a measurement for the width of the stack, and for the height of the stack, and then for the length of the stack. In this case, we're going to keep it simple, and we're going to say 5 feet, 5 feet, and 5 feet. Then we do a very simple calculation where we go height times length times width. In this case, that's 5 by 5 by 5, which equals 125 FBM. Now I'm quickly going to discuss standing tree measurements. Essentially, all we have to do in a forest is if we have a series of trees that are standing and we know their species, an individual can come up with a DBH tape, which tells you the diameter of a tree by wrapping it around the trunk. And from that, we record the species, in this case, which we'll say is hard maple, and the DBH, which in this case we will say is 20 centimeters. Then we take that 20 centimeters and that species, and we'd simply apply it to local factor tables, which are provided by the ministry, and we would have a volume for that stand. We can apply this across cruise sheets, and then we can get an idea of what kind of material is standing in the bush and what kind of material we'll be getting out of it once we've done that.
I hope you enjoyed our short summary of scaling.
As you can see, finding the volume of mercantile lumber in a log is a very easy process that can be done using a small amount of equipment and just a calculator using simple math.